Here's the question we're going to be looking at today, where we're told two different maths classes took the same maths test and were given their scores. In part A, we're asked to construct a back-to-back stem and leaf plot of the above data. Now the first step is to fill in the actual stem of the stem and leaf plot, and the numbers that go here is the first digit of every two-digit number. Now since our data starts with single digits and goes up to the 80%, we have to write the numbers from 0 to 8 in the stem. The next step is to fill in the zero leaf for the stem and leaf plot. So we have to go back through all the data and find any single digit percentages. When you do this, you'll find that there's 1 in class 2, which is 9%. So we write the digit 9 to the right of the 0 in the stem of the stem and leaf plot. And now we have to move on to the 1 leaf. So now we have to go back through all the data again and find all the percentages between 10 and 20% and underline them. When you do this, you'll find that there are 3 of them, one of which is in class 1 and 2 are in class 2. So the one in class 1 is 14%, so we have to write in the digit 4 to the left of the 1 stem. Now there are 2 in class 2, one of them is 12% and the other is 15%, so we write in a 2 and 5 on the right hand side of the 1 leaf. Now we continue on in this way until we have all of the data filled in to the stem and leaf plot, and when you do so, it should look like this. Now all that's left to do is draw in the key. Now you can use any number for the key, but what you have to show is that, for example, 12% can be written as 1 line 2. And this is so the person reading it can understand your stem and leaf plot. That's the answer for part A. Moving on to part B, we're asked how many students were in each class. For this, we can simply go back to the start of the question and count how many values are in each class. And when you do that, you'll see that there are 15 students in class 1 and 18 in class 2. So that's the answer for part B. In part C, we're asked the data about the student scores collected here is an example of which type of data: categorical nominal data, categorical ordinal data, numerical discrete data, or numerical continuous data. Now since the data we're talking about here is test scores, which is measured in percentages, this is numerical discrete data. So that's the answer for part C. In part D, we're asked what is the interquartile range for each class group. Now to find the interquartile range, we have to find the value which has 3/4 of the data below it, and the value which has 1/4 of the data below it. Now since there are 15 students in class 1, if we multiply 1/4 times 15, we get 3.75, which means that the fourth value will have 1/4 of the values below it. Now if we go back up to the stem and leaf plot, where the data is all in order, we see that the fourth value in class 1 is 4, 4, or 44. So that's the first value we needed to find. Next, we multiply 3/4 times 15, which gives us 11.25, and this means that the 12th value will have 3/4 of the data below it. So once again, going back to the stem and leaf plot, the 12th value in class 1 is 77. So that's the second value we needed to find for class 1. Now we can find the interquartile range for class 1 by taking 44 away from 77, which gives us 33. Moving on to class 2, we multiply 1/4 times 18, since there are 18 students in class 2, and this gives us 4.5, which means that the fifth value will have 1/4 of the values below it. And the fifth value for class 2 is 24. Now 3/4 times 18 is 13.5, which means we're looking for the 14th value. And for class 2, this value is 50. So the interquartile range for class 2 is 50 minus 24, which is equal to 26. So that's the end of part D. In part E, we're asked to explain the meaning of the term outlier and give one example from the data above. So an outlier is an extreme value or a value which is far away from the rest of the data. And an example of this would be the value 14% in class 1, and you can see this by looking at the stem and leaf plot, because the value of 14 is far away from the rest of the data, which is between 40 and 90%. So that's one answer that you could give for part E. Finally, in part F, we're asked which class do you believe achieved better results in the test. Now, one way to quantify which class got better results is to find the mean result of each class and compare them. So the formula to calculate the mean is the sum of values divided by the number of values. Now in class 1 there are 15 values. So to find the mean, you take the sum of the values and divide by 15, whereas for class 2 there are 18 values. So you take the sum of the values and divide by 18. And when you calculate the mean for class 1, you get an answer of 60.67%, correct to 2 decimal places, and for class 2, we get a mean of 41.22%. Now clearly, since 60.67 is higher than 41.22, we can conclude that class 1 achieved better results as they had a higher mean. So that's the answer for part F, and that's the end of this question. I hope you found this solution video helpful. Thanks for watching, and I'll see you again.